Good early afternoon. It is 20 minutes past 2. Nice sunny day. Not too bad out there. Got the shop door open here. I finished pulling apart the Silvertone reel-to-reel, and I literally had to bust up the pulleys in order to get them off. That they're glued on with them little press-on washers that they use. I showed you in the last video. So unfortunately, I couldn't get the motor assembly out without cutting the flat belts. Just had to do it. The only way I could get it out. I couldn't shift the motor one way or the other. So that's just the way it is. And I put all the metal into the recycle and save the motor assembly. This pulley don't seem to come off. Not a problem. We'll just save it as a complete unit, and it might come in handy for somebody might need it for their tape recorder or something. It would cost a few bucks to ship it out, but if somebody needs it and willing to pay for the shipping, I got on the bench here the power transformer. I do not have the schematics. To my surprise, the secondary wires do not have a center tap, and the output voltage is the same as the input. It's 115 volts. So I'm going to get you a little closer here and show you the readings that I'm getting on here. So let's get you over to the bench so you can see. And I know some of you are probably saying, well, Jesus, don't you have any other videos besides the electronic ones? No, I don't. I don't have anything else going right now. So let's go over to the bench here. First, we're going to use the Simpson 260 on resistance. And I'm a little puzzled. Maybe you guys out there that are much more knowledgeable can answer a strange question that I have here. Okay, this is not plugged in. This is a little piece of extension cord that I had that I used to just connect up my primary. The primary on this transformer is not the two black wires, but rather a green wire and a black. Okay? I ohmed all this out, and all there is on here is the input, 115 volts, a 6.3 volt secondary, another 6.3 volt secondary, and 115 volt secondary. This appears to be a center tap, but it is not. You would think this one would be a center tap, but it is not. I get 0.3 ohms across here, 0.3 ohms across here. These are the two 6.3 volt filament windings. There is no center tap for either one. There is no center tap for the high voltage, such as it is. The first thing I'm going to do here is put my clip leads on the secondary. The transformer is not plugged in, and we've got the meter set to ohms. So we got to find our other lead here and connect up my ohm meter to the other end. Okay, on the secondary, I don't know if you can see that, and we'll try to zoom in a little bit. I know it's digital zoom. What we're getting is 30 ohms. looking at the top scale. We're getting 30 ohms on the secondary, okay? Now, I'm going to take these leads and I'm going to put them on the primary. Remember now, the secondary is putting out 115 volts. It's almost like an isolation transformer. It's a 1-to-1. I was kind of disappointed. I was hoping this would have a high voltage secondary on it. Okay, so we're going to take these leads now off of the secondary and we're going to put them on the primary right here. Okay, and what we get now is 10 ohms. 10 ohms. Top scale right here. Now, why am I getting 10 ohms on the primary and 30 ohms on the secondary, which would normally be correct if this was a high voltage secondary, but it isn't. This is 115 volts coming out, and we're going to verify that now by putting my meter on it. Okay, just to show you my mess here I dragged out one of my digital meters here. A little easier for me to read. Set it on AC volts. We got the clip leads connected to the secondary of this transformer. We're going to flip on the isolation transformer. I've got 116, 117 going in. Okay, we got you a nice close-up of the digital meter. And we are set on AC volts. We're going to flip on the isolation transformer now. Okay. We're going through the dim bulb. Now we bypassed the dim bulb. 114.3.4. That's the output of the transformer. Now, I doubt there's any shorted turns on the secondary, which would result in a lower voltage, but it would also cause the dim bulb to light. The dim bulb does not light, and the transformer is running ice cold, because I've had it on before I was on camera here. Right here. Now, very carefully, removing the leads and placing them on the primary, we're getting 115.9 volts. We're running through the isolation transformer. We are bypassed. I got a bypass switch up here on the dim bulb, but we always keep the dim bulb in circuit. So as you can see, the secondary and the primary are essentially the same. Okay, now I got my test leads on one of the 6.3 volt windings, and on the Simpson 260 it read about 7 volts. And there we go right there, 7 volts. So we're reading 7 volts on this one, and 7 volts on this one. There is no ties between these. We're getting phantom voltage there because we're using a high impedance meter. So there is no resistance, leakage, or anything, because I made this test with the Simpson and I got 0 voltage. This is what they call phantom voltage, or there's capacity between the windings in the core and so forth. There are several good videos on testing transformers. One of them is Uncle Doug, whom I've subscribed to, and another good one too is All American 5 Radio. He's got some good videos. His audio is quite muffled though, and he's a little hard to hear. He doesn't, I don't know what kind of microphone he's using, but I do watch his videos, but it's a little hard for me to hear him because he doesn't have the crispness in the audio, and it's quite difficult for my ears to really hear him, and I have to turn up the volume. But anyways, there's 2 good videos there, and All American 5 had, answered a question by somebody that wanted to know why they were getting voltages between windings that were not connected. Okay, I have the ohm meter set on the lowest range. It's reading 8 ohms on the primary. Okay, this is the primary right here. So let's bring the leads over to the secondary. And yes, I made very sure that we're unplugged, and because that would destroy my meter. We're reading 29.3, so thereabouts 30 ohms. Okay, I could understand having a higher resistance reading on the secondary if the secondary was putting out more than 115 volts. Let's say 200 or something, or 300. Now, I understand the windings probably are thinner, and that's the only explanation I can come up with as to why the resistance is 3 times higher for the same 1-to-1 voltage, which is basically what this is. So maybe it's because of the thinner wire. That's the only explanation, and maybe that is the reason. Now, I don't have the schematic of this to find out what the output voltage is supposed to be. Maybe Buzz will chime in, look at his schematic, because I know he's got one, and see what this transformer is listed in the SAMs as the AC output. A lot of times they will list it, not always. This tape recorder that I got this out of only has 2 diodes in it. So it's hooked up in such a way, there is no center tap here. And I'm going to prove that there is no center tap on the secondary. And we'll prove that by using this meter here. We're going to take off one of these leads. We're going to put the ohm scale up a little bit. And we're going to put it on what I would think would be the center tap, but it isn't. This is a 6.3 volt winding over limit. I'm going up in resistance. It's basically infinity. I found out that this meter here will read 2,000 megohms. This will read a 100 megohm resistor with no problem whatsoever. I had thought that I didn't have a meter that would read that high, but yes, my Fluke 73 will only read about 20 megs max. And this will only read to 20 megs. But this Radio Shack here, this reads way up there, but you can see that there is no center tap here, This is one winding, so it ain't going to make a difference. Very low resistance here. So let's go on over to this one. Okay. Again, no center tap. So now let's check leakage. There is no leakage between the transformer case and the secondary. We got this meter set at the most sensitive range it can be. Now it's not going to matter if I go to this one because you're talking 30 ohms, so that's not going to matter. Again, no leakage. Let's check the leakage between the 6.3 and the case. No leakage. In other words, there's no shorts or leakage to the case from any windings in this transformer. So it's a good transformer. We'll test the other one. Again, okay. Now we'll do one last check. One side of the primary. Again, over limit. No leakage. Okay, we got my leads I made up. No noticeable resistance drop. We're going to check the resistance using this one. We're on the primary. Unplugged, of course. 7.8 ohms. Okay, let's go to the secondary. All right, we're on the secondary. 29 ohms. So I just wanted to give a little rundown on this. So if Buzz 1151 happens to be watching this whenever, he's on the West Coast, so he watches his videos much later in the day. Maybe he might have the schematic. I don't know, Buzz. If you have the schematic, could you take a peek at it and tell me whether this transformer shows any voltage readings? I'm pretty sure this transformer is okay. It's ice cold. It didn't draw any current. No light on the dim bulb. No current, noticeable current draw on the amp meter. So I'm pretty sure the transformer is okay. Alright, so that's it. I just wanted to know the information as to why, or the answer I should say, as to why I'm getting roughly 9 ohms on the primary, which is normal, 6 to 10 ohms on the primary, 115 volt, and I'm getting 30 on the secondary, but yet the secondary only puts out the same as the primary, 115 volts or whatever. If you're putting in 120 here, you're going to get 120 out here. So it's basically an isolation transformer, a filament, a two winding 6.3 volt filament transformer, one here and one here, combined with an 1-to-1 isolation transformer, low wattage, probably maybe a couple hundred watts, maybe not even that much. I would probably say 100 watts. It's not a very big transformer. So I'm going to label these with masking tape and put it in my inventory. Thank you for watching.